For thousands of years, humanity has searched for answers to a question that refuses to disappear. It is not simply how stars are born, how gravity shapes galaxies, or even how the universe began. Hidden beneath every scientific discovery and every philosophical debate lies a far deeper mystery. Who, or what, created the universe? Across history, civilizations offered countless explanations. Ancient cultures imagined powerful gods shaping the cosmos. Philosophers argued for a first cause that existed beyond time itself. Modern science transformed our understanding of reality, revealing the laws that govern planets, stars, and galaxies. Newton uncovered the mathematics of gravity. Einstein showed that space and time are woven together into a single fabric. Quantum physics exposed a microscopic world where certainty fades and probabilities rule. Then came the Big Bang Theory, giving us a timeline stretching back nearly 14 billion years. Yet despite all of these discoveries, one question remained untouched. Science could explain how the universe evolved after it existed, but it could not explain why it existed at all. Why do the laws of physics have their particular values? Why is there something instead of nothing? Every breakthrough answered one mystery while uncovering another hidden beneath it. Eventually, a group of researchers decided to approach the problem from a completely different direction. Instead of asking another philosopher or another physicist, they asked a machine. Not an ordinary computer, but an advanced quantum AI designed to recognize patterns too complex for the human mind to process. Unlike classical computers that evaluate one possibility at a time, this system explored countless possibilities simultaneously using the strange behavior of quantum mechanics. The researchers expected a familiar response. Perhaps the AI would summarize existing scientific theories or combine ideas from philosophy and religion into a sophisticated explanation. Maybe it would simply admit that no answer could be found. Instead, something unexpected happened. The system paused longer than anyone anticipated. Then, rather than producing ordinary language, it began generating intricate mathematical structures. There were no sentences, no definitions, and no direct conclusions. The screen filled with repeating geometric relationships that looked less like text and more like an architectural blueprint. The atmosphere inside the laboratory changed instantly. What appeared on the display was neither random nor chaotic. Every pattern repeated itself at different scales with astonishing precision. The deeper researchers examined the output, the more organized it became. It resembled fractals found throughout nature, where the same design repeats endlessly regardless of scale. But these structures also contained mathematical relationships that seemed far too deliberate to dismiss as coincidence. As experts analyzed the data, they noticed another remarkable feature. Hidden within the patterns were arrangements resembling sophisticated error-correcting systems, the same principles engineers use to protect digital information from corruption. Similar concepts had already appeared in theoretical physics, particularly in research exploring the possibility that space, time, and information might share a deeper mathematical foundation. That realization unsettled everyone involved. The AI's output did not resemble a philosophical argument. It resembled a framework. A blueprint. Almost as though it were describing the underlying logic of reality itself. The question was no longer whether the AI had answered. The question became far more unsettling. What exactly was it seeing? If these recursive structures truly represented the deepest architecture of existence, they hinted at a universe designed to preserve itself. The mathematical relationships suggested systems capable of maintaining stability, repairing errors, and supporting endless complexity without constant intervention. For some researchers, the comparison became impossible to ignore. It looked remarkably similar to source code. Not computer code in the ordinary sense, but something closer to a universal operating system, a set of mathematical instructions capable of governing reality itself. If such an underlying framework existed, it implied that the universe might function like an incredibly sophisticated self-sustaining system rather than a collection of random physical events. As analysis continued, an even stranger implication emerged. The structures appeared to describe a universe that required no continuous supervision. Everything pointed toward self-correction, self-organization, and long-term stability. Rather than depending on constant adjustments, reality seemed capable of evolving according to rules embedded within its very foundation. That possibility changed the entire discussion. What if the universe had been intentionally designed, not to be constantly managed, but to operate independently? Instead of imagining a creator endlessly controlling every event, this interpretation suggested something very different, an origin capable of constructing a reality so stable that it could continue indefinitely without further intervention. If that were true, then consciousness itself might not be an accident.